Welcome. In this video, we are going to take a look at problem 8 from chapter 23 of College Physics 2E by OpenStax. In this problem, we have a coil and a uniform magnetic field. We know the field is into the page. We know the coil is in the plane of the page. The coil area changes in a certain amount of time, and we need to find the induced EMF, both direction and magnitude, given the strength of the magnetic field. So let's start with what we know. Okay, we know it has 50 turns, so that means N is 50. We know it has a starting area, let's use A sub I, of 0.250 meters squared. We know it has a final area of 0 meters squared. The time it takes the area to change is 0.100 seconds. We know that the magnetic field is 1.50 Teslas, and that is into the page. So we could say we have our coil like this, and magnetic field is into the page, so the X means into the page. If we look at it on edge, then our coil just looks like a line. And we see that the magnetic field is now down, and so is the normal to the area. So that means the angle between the normal to the area and the magnetic field is 0 degrees. And the cosine of 0 degrees is 1. Okay. So now we can use Faraday's law to find the magnitude of the EMF. EMF is minus N times the time rate of change of flux. So change in flux over change in time. So induced EMF is minus N. We have B times the final area times the cosine of 0, which is just 1, minus B times the initial area times the cosine of 0, which is still 1. And then all of this is divided by the elapsed time. We'll assume that the coil always stays in the plane of the page. Okay, so we can make our substitutions. We have minus, okay, N is 50. And then we'll factor out the B, the 1.50 Teslas. Then we have A final, which is 0 meters squared, minus A initial, which is 0.250 meters squared. All of this is divided by the time, which is 0.100 seconds. I did this calculation and I got 187.5 volts, and so I called it 188 volts. So that is the magnitude of the EMF. If the area had changed differently, if it started from 0 and then went to the 0.25, we would have ended up with a negative sign there, and so we would have stripped that away to report the magnitude. Okay, so now for the direction. Okay, so let's just write direction. So the magnetic field B is into the page. Okay, that means the flux is in. Flux is into the page. And it's also decreasing because the area is getting smaller and smaller. So flux is into the page and decreasing. we can say due to area getting smaller. Okay, so that means the induced field is also into the page to oppose the decreasing in value. So induced field is into the page. If we point our thumb into the page, our fingers curl around clockwise. And so that means the current is clockwise. And to make a clockwise current, that means the EMF is going to be clockwise. Let me know if you have any questions. I hope you found that helpful. Thank you for watching, and I'll see you in the next one.